Okay, I'm back, and now we want to talk about the Earth's magnetic field. So what causes magnetism? Well, one thing that causes magnetism is bar magnets. So hopefully you have done this little experiment in elementary school where you take a bar magnet and you cover it with a piece of paper, and then you take some iron filings and you sprinkle them on top of the piece of paper, and then what happens is it makes an outline of the magnetic field of a bar magnet. So if you want to see how that's done, you can watch this little video called Seeing Magnetic Field Lines on MagLab. But there's another way of making magnetism, and that is through the use of electricity. And so again, I'm hoping that you've done this in elementary school. You need a nail, you need some wire, you need a battery, and so you take the wire, you wrap it around the nail, you attach the two ends of the wire to the battery, and lo and behold, it turns that nail into an electromagnet. So it's using electricity to make magnetism. And you should be able to pick up like a paper clip with it. So it's not really that incredibly powerful, but you get the idea that electricity can make magnetism. And notice the shape of the magnetic field. So I would like for you, if you're going to be taking my class and you're going to be taking the exam, you should be able to draw the magnetic field of the Earth. And so it's going to look something like this. It's going to come out and it's going to go in, come out, and then go in. And this is actually a south magnetic pole. And then this is actually a north magnetic pole. So you might be thinking, oh, that's wrong. This should be north up here. Well, it's north geographic pole. And then this would be the south geographic pole. But magnetically speaking, this is a south pole. Because if you've got a compass, which way does a compass point? It points north. Well, what is a compass? A compass is a tiny magnet. So if you've got a compass, and then this is the north arrow of the compass needle, it's going to line up with this magnetic field. And so north would be attracted to south. So that just goes to show you that what you kind of think of being north is really south, and south is north, and well, let's not really get into that. But if we want to put some arrows on this thing, then coming out of the north, we would want to put the arrows coming out, and then the arrows go in to the south side. So I would like for you to be able to make a picture showing the magnetic field of the Earth. So what causes it? Well, originally, the original theory was that inside the Earth was a magnet, because we know that a magnet can make magnetism. So therefore, they thought that inside the Earth was a permanent magnet that made the magnetic field. Well, then they found out, though, that you can destroy magnetism when you heat it. So if you take a magnet and you heat it up, it destroys its magnetism. Well, we know that inside the Earth it's very hot. So there can't be a permanent magnet inside the Earth. It's just too hot. So then that leaves us with the other theory. So the other theory is it has something to do with electricity. So what we need is something metallic, like the wire when you wrap it around the nail, that is going around and around inside the Earth. So that metallic material is going to be the iron and nickel in the core of the Earth, the outer core. So the magnetic field originates in the outer core of the Earth, where you've got this liquid iron and nickel that is going around and around. What would the solid inner core, what would it do? It would be like the nail. So you got the nail, and then you wrap it with the wire. So the nail intensifies the magnetic field of the Earth. It doesn't actually cause it, but it does make it stronger. So as this material goes around and around, it's got electrical charges, and then that's creating electricity that is making the magnetism. And it's more complicated than that because it's really called a geodynamo theory, in which the metal is creating a magnetic field, and then the magnetic field that it's creating is making the electricity, which is making the magnetic field, which is making the electricity. So if you want, go to the internet or an encyclopedia and just type in geodynamo theory. And that's the real theory of the origin of the Earth's magnetic field. So what I want you to know, though, is that it's in the outer core, and it's caused by liquid iron and nickel going around and around. Oh, why is it going around and around? Okay, so what's the Earth doing? The Earth is spinning. So as the Earth spins, it causes this material to go around. Now, it's worse than that, because we said the inside of the Earth is hot, so the inside of the Earth is convecting, which means that the material is going up and then down, up and down. At the same time, it's going around and around. And so what that does is it tangles the magnetic field inside of the Earth. And eventually that magnetic field gets so tangled, it snaps. And then when it reorients itself, north is south and south is north. The magnetic field of the Earth flips about every 100,000 years. And again, it's due. The magnetic field of the Earth has decreased in the past 100 years by about 5%. We don't know if that means that the magnetic field is going to flip or if that's just a normal phenomenon. But about every 100,000 years or so, the magnetic field of the Earth flips. And that can be really bad, because when that happens, it's going to allow radiation to come through the atmosphere. Our magnetic field protects us against cosmic rays from the sun. So without that magnetism, some of that radiation will hit the Earth. And there are biologists that say that that is what causes evolution. So every 100,000 years or so, you have more mutations as a result of this incoming radiation, and then maybe that's what drives evolution. So we don't really know, but that is a possibility. In our next segment, we're going to talk about surface features of the Earth and what causes them. So I'll see you in just a few moments.